Hello, my name is Adriana Prida from Miami-Dade College, and today I will be speaking to you about how temperature affects chemical reactions. What are chemical reactions? Chemical reactions occur when atoms from a molecule basically collide and they break their bond and create new bonds. They're at the heart of every biological process that we know, whether it's fire, cooking, photosynthesis. Chemical reactions occur to create these things and they help us understand how they work. Without them, basically nothing would be created. There would be nothing new and everything would be really boring. Let's take a closer look into chemical reactions. One of the factors that are really important for chemical reactions is the rate at which they happen. Things like the concentration, the temperature, the physical state, catalyst, and light all affect the rate at which chemical reactions happen. This term is known as the chemical reaction rate. In order for particles to collide efficiently, they must have the right amount of energy and their orientation so they can break and rearrange into whatever product this may be. This is known as the collision theory. The collision theory states that particles need to have the exact amount of energy in order to collide successfully and create a different product. Activation energy is the minimum amount of energy that it needs to carry this process into the transition state where the actual reaction happens. The higher the activation energy, the longer the reaction will take. And the lower the activation energy, the less time the activation will take. As we can see in this graph, not a lot of particles actually get to the amount of activation energy that they need in order to go through the reaction process. So how does temperature affect this process? Temperature is basically measured by the kinetic energy, or the amount of kinetic energy, which is how fast the particles around it move. So the higher the energy, the faster the particles move. By increasing the temperature, you increase the heat energy at which the molecules move, which makes the movement faster, and they are able to collide into each other quicker and increase the chemical reaction rate. Nonetheless, this doesn't mean that increasing temperature always guarantees a faster reaction rate. In order for it to actually work and have a faster reaction rate, it must surpass the activation energy. As we can see in this graph, where T represents the activation energy and T plus T represents the activation energy plus the heat, there's a lot more particles that actually get to go through the transition phase, or where their reaction occurs, almost twice as much as without the increase in temperature. The Chatier principle, also known as the equilibrium law, states that if any system experiences a disturbance or a stress in whichever of these factors that I mentioned before, concentration, physical state, temperature, catalyst, or light, it will respond to create an equilibrium. The effect of temperature specifically really depends on whether the reaction is endothermic or exothermic, which is determined by the enthalpy. If the change in enthalpy is negative, then the reaction is exothermic and it releases energy, leaving heat as a product. But if the enthalpy is positive, the reaction is endothermic and it absorbs the energy, leaving the heat as a reactant. So whichever side you're on, endothermic or exothermic, higher temperature means more heat. So the equilibrium will shift to the opposite side and consume the excess heat to relieve the stress. As you can see in this table, in exothermic and endothermic, when you increase the heat, the equilibrium shifts to the opposite side of the product or the reactant. So how are chemical reactions applied in our very own community? As I said before, chemical reactions are literally anywhere and everywhere. They take part in most of our lives, whether it's when we wash our hands, when we brush our teeth, when we cook, but most specifically in engineering. For the industry, chemical reactions are very important because they are used to innovate and create new ways to meet the demands of the consumers. And also, they create procedures for safety and pollution control. Also, observing chemical reactions help us understand not only our natural world, but in outer space. We can identify and explain or describe other planets and determine whether they are able to sustain life. So as you can see, chemical reactions are not just limited to a chemistry classroom, but basically take part in most of our lives and most of what we know without us even thinking about it. Thank you so much for your time. Have a nice day.